Okay, good morning everyone and welcome to the ORAC 2.0 informational webinar series. My name is Paul Wrigley. I'm the Vice President of ORAC and also the co-chair of the Associates Committee. I'm also joined by Amy Carpenter and Jessica Shaver at the ORAC office. Both will be helping with technical issues if we have them and moderating questions. Before we jump into the webinar, I'd like to do a quick Zoom tutorial. I know most of you are probably experts at using Zoom nowadays, but we will quickly touch on a couple of points that are relevant to this webinar for those who are not familiar with the platform. Please ensure that you are logged into this Zoom webinar on either a computer, a smartphone, or a tablet so that you can access all features of the webinar. All attendees in this webinar have been muted to provide the best experience for both the presenters and the viewers. If you have any questions during the webinar, please enter them in the Q&A box, which you can access with the tab at the bottom of your screen. Your questions will then be answered either directly in the Q&A box or verbally by the presenter at the end of the presentation. Today's presentation is the fifth in our series of webinars, and today's guest speaker and sponsor is Trevor Woods from KeepRite Refrigeration. Trevor's presentation relates to regulatory updates in the commercial refrigeration industry pertaining to new refrigerants and energy efficiencies. Trevor is a graduate of Humber College with diplomas in both air conditioning refrigeration and in energy management. Trevor has been in the industry for 16 years, currently as commercial sales representative for KeepRite Refrigeration, covering Ontario and the Maritimes. His product lines include specialized applications in food storage and processing, industrial process cooling, including evaporator coils, condensing units, condensers, heat transfer, and heat recovery, as well as air conditioning products. At this time, I'd like to turn the screen over to Trevor Woods with his presentation. Thank you.
Hey, Paul, thank you for the introduction. I'm going to be talking today about commercial refrigeration regulatory updates. We've had a lot of change in the industry this year, from things such as refrigerants to energy efficiency regulations. So I'm going to go over those with you today. So I'm sure there'll be lots of questions, so please feel free to ask. And again, I want to thank everybody for being on this webinar and for your time here today. Next slide, please. So the refrigeration industry, it's kind of been under the microscope for some time now. You know, government bodies from around the world have kind of been taking a look at it, trying to see what kind of changes can be made in terms of more environmentally friendly refrigerants, better energy efficiency. So things kind of started rolling in Europe, and we've seen it come over to North America here. So everybody's kind of been focused in on the industry. Next page, please. So what's driving it in North America and a lot of countries around the world is something called the KEGALI. And I'm just going to kind of go over the basics of what that amendment is. So basically, it's an agreement that makes an amendment to the Montreal Protocol. So that was a global treaty to eliminate the use of ozone-depleting substances. So, you know, we were using HFCs as a replacement for ozone-depleting substances because we were putting a hole in the ozone layer. But then we found that those HFC refrigerants were a major contributor to global warming. So basically with the KEGALI agreement, there's a phase down in the use of HFCs by 85% by 2036. And this already went into force on January the 1st, 2019. So Canada kind of falls in that red box there, the A2 countries. So you can kind of see what the steps are in terms of phase down. So as of I think there's about 65 countries that have ratified so far. And it's important to note this is a phase down, it's not a phase out of HFCs. Next slide, please. So we're kind of doing a two-pronged approach here in Canada. So we've got the quota system in effect. And then what Canada's also doing is they've put a product-specific control on different types of products in different industries. So they've put a global warming potential limit. So you're going to start hearing me refer to global warming potential as GWP as short in the next slides here. But you can see from this table that there's a few industries affected. At KeepRite Refrigeration, the equipment we build that's affected falls under that centralized refrigeration systems and condensing units, which is 2,200 GWP as of January the 1st of this year. So you'll see some other industries as well, such as standalone medium temperature refrigeration and standalone low temperature, so both commercial and domestic. So they've got different GWP limits coming in 2025 for domestic. So, you know, things like your household refrigerators. You'll also see chillers and mobile refrigeration on this list as well. Next slide, please. So basically what happened at the beginning of this year is that 404A refrigerant and 507, which have been around for a long time and have kind of been the main refrigerants being used in refrigeration, you can no longer use them on a new installation. So the government put that hard line in at 2,200 GWP. If you're using any new refrigerants, they've got to be under that limit. So you'll see in the middle of the screen there in the red box, that's the refrigerants you're going to see now mainly in the industry. So 448A, 449A, 134A is still around, 407C and 407F. Also put R410A in here. That's an air conditioning refrigerant, but just to kind of give you kind of a mark as to where the GWP is compared to the refrigeration refrigerants. And then you've also got your 407A. Now there's a lot of other refrigerants that are out on the market that have GWPs much lower than that 1400 there. Now there is some challenges with those refrigerants. You know, you get into issues such as high pressure, if you're talking about CO2 systems. Ammonia is a great refrigerant, but it's also toxic, so it's kind of limited to its applications and where you can have that installed. You'll also hear a lot of talk these days about propane as a refrigerant. So propane's got a limit charge of 150 grams right now, so it's kind of limited to what you can use it in. But it is getting more popular, and there is other refrigerants out there that are blends, HFCs and that, different blends that have some challenges with low temperature capacity and that, but we'll talk about that a little bit later on here. So if you want to go next slide. In terms of capacity, the new refrigerants out there, they're pretty similar in capacity. On this table here, I'm comparing on the y-axis, you'll see your capacity in BTUs per hour, and along the x-axis there, you'll see your box temperatures. And you can see that depending on the box temperature and where your suction temperature is going to be, whether you're talking 407A, 448, or 449A, those refrigerant capacities are fairly similar. So this is looking at a medium temperature application for a cooler. Next slide, please. And here would be a low temperature, sorry, just go back one. So here's a low temperature freezer. You can see your different capacities as well, and very similar to what you see in the past. I've even got our 22 in there just to kind of give you an idea where they stack up. Okay, next slide, please. So really where the industry is heading is, if you take a look on this chart here, that legacy box on the far right of the graph, that's the refrigerants we've been using. And now we're going to that box number 2 there. So those are the new refrigerants you're going to see in the industry today. So basically the industry is moving to the left. We want to get away from high GWP refrigerants. And you'll see there in box number 1, that's your CO2, your ammonia and propane. So you can see they're very close to 0 GWP. Very good refrigerants, and you can see why those have kind of become popular. And where we see the industry heading for us with the other refrigerants is that box number 3. So in box number 3 there, you'll see there's quite a few refrigerants that are kind of under that 500 GWP limit. And the one thing I'll point out on this chart is those refrigerants that you see in the pink boxes, they are mildly flammable. So until we make some changes to building codes and how insurance companies work, those refrigerants we can't use at this point, but there is task force in place trying to get those approved. So that's where we see the industry heading. Next slide, please. So I guess at this point, while we're talking about refrigerants, before I move on to some of the other regulations, is there any questions so far on the refrigerants?
Just give a couple minutes if people want to type any questions in now.
Yeah, please feel free. If you have any questions as you think of them, just leave them till the end here, and we can answer those as well.
Perfect. Doesn't look like there are any right now.
Okay. Yeah, so just kind of finishing off on the refrigerants, where we see the industry heading again is low GWPs, probably below 150. California's already got something in place where they're going for refrigerants that are going to be below 150. Quebec's also got a proposal that looks like it's going to take effect January the 1st of next year, which they're looking at refrigerants below 150 as well. So there are, I'm showing here refrigerants that are out there. These are all mildly flammable, all right, but they all act like a 404A refrigerant. So they're just different blends, different companies making them, but they do exist, and you probably will see them in the near future. Next slide, please. All right, so what do we really need to know about refrigerants today? So again, the industry, it's moving away from these high global warming potential refrigerants. We want to try and get as close to zero as we can. R404A and 507, which has been around for a long time and is a very popular refrigerant. Can't use it for new installs anymore, but having said that, you can still use it for replacement. So if you were replacing, say, just a condensing unit in a system or just an evaporator, you can still use 404A components there. So 404A, it's going to still be available for, component replacement or service of existing equipment well into the future. It's kind of like what you've seen with R22. It's phased down, but it's not phased out. You can still get the refrigerant. Main refrigerants you're going to see going forward from the manufacturers are R448A, 449A, 407A, and 407C. There are some other ones as well I didn't mention there, but those are kind of the main ones you're going to see. Now, one thing to keep in mind with these new refrigerants, they're blends, and they do have a high glide on them. All right, so it's a little bit trickier to troubleshoot. You might see some different frosting patterns on the coils. So just some different things you got to look out for there. Okay, next slide, please. All right, so we're going to change gears here a little bit, and we're going to talk about something called annual walk-in energy factor, or AWEF for short. I'm going to refer to it as AWEF in the next slides. But what the annual walk-in energy factor is, it's something that the Department of Energy in the U.S. came up with, and Enercan here in Canada has followed suit. So same regulation in effect both north and south to the border, and it's for commercial coolers and freezers that are under 3,000 square feet. Okay, these new regulations, they establish a minimum efficiency level for refrigeration equipment. So kind of neat because we've never had that in the refrigeration industry before. If you look at the air conditioning industry, we talked about EER, and so now we finally have an energy efficiency regulation in refrigeration. So, it applies to all the different types of refrigeration equipment, and it's really put a lot of change into the industry. A lot of the manufacturers have had to make some pretty big changes to their equipment to be able to get to the efficiency levels they require. So we'll talk a little bit more about what those levels are here. So next slide, please. So to better understand AWEF, there's some important definitions. So basically, it only applies to walk-in coolers or freezers less than 3,000 square feet. To give you guys an idea, a box that's 50 feet by 60 feet, that's 3,000 square feet. So you know that in the industry, you'll see a lot of boxes that are a lot smaller than that. So it really does impact those general storage coolers and freezers that you see in the industry. So box temperature, it's defined as being greater than 32 degrees Fahrenheit. A freezer is anything that's equal to or less than 32. Now, a dedicated condensing refrigeration system is one of the following types. So it's either a dedicated condensing unit, a single package dedicated system, so that's just a packaged unit. You might have a matched refrigeration system where you've got the condensing unit and evaporator. Now, that dedicated condensing unit, it's further defined as having one or more compressors, a condenser coil, and one refrigeration circuit, and it only is designed to serve one refrigeration load. Okay, so if you've got a unit serving multiple boxes, it would not have to comply with the regulation. Next slide, please. So in a nutshell, the way I want you to think of AWEF as your seasonal energy efficiency ratio that you would have in air conditioning. They are calculated almost identically. They're expressed as BTUs over watt hours. And basically, it's a ratio of how much heat you're taking out of the space to how much work you're putting in. Now, the one thing that's a little bit different with AWEF is that you have to have an efficiency for each one of your components, so the evaporator and the condensing unit. Next slide, please. So here's a look at what those efficiencies are. And don't worry about memorizing these numbers or that. You'll find that all manufacturers have listed what their efficiency levels are for their equipment, and they'll show you if they do meet these levels or they don't. But basically, you see the efficiencies are broken down by the different types of equipment. So medium temperature condensing units, they came into effect on January the 1st of this year. And then you'll see below, you've got your low temperature condensing units and your evaporators. They went into effect on July 10th, so just a month ago. And basically the low temperature stuff, it's broken down by capacity, and these are the new levels you have to meet. So, you know, manufacturers, they've had to do some significant testing and modifications to equipment to be able to meet these levels. So we'll talk a little bit more about what those changes are here. Next slide, please. So what we did at KeepRite, we came out with our Generation D condensing units there last year. What we did is we've added more surface, so larger coils to some of the models. We're using ECM fan motors on some sizes, and we've eliminated some sizes just due to compressor efficiency. So, you know, other manufacturers, you're going to see similar things. You might see microchannel condenser coils. You might see a whole redesign on their condensing unit. You might see floating head pressure controls. That's a few of the ways that the industry is kind of adjusting to this. Next slide, please. Same thing on our evaporators. So again, they just went into effect on July 10th. We're using ECM fan motors as standard now on those. And one thing you'll see is that lower fan speeds will be on most models. So, you know, if you look at the fan laws, you've got that third fan law that's got the cubic relationship between fan speed and horsepower. So, you know, slight reduction in speed is a good reduction in horsepower. So it's a way to save a lot of energy. So we've done that. We've done enhanced tubing on some models. But other changes you might see in the industry, you might see people using larger evaporators, you know, increasing their surface by adding more rows, or maybe more fins per inch in there. And the one thing to note, what we're doing on our equipment is that we'll still have you'll use a 2-speed ECM fan motor for projects that are less than 3,000 square feet to meet the regulation. But if you have a larger job, you can use a regular PSC motor. And one thing for us here in Canada is 575 volts, you can't get an ECM motor in that voltage. So 575 volts, you're actually exempt from the regulation. Next slide, please. Now, one thing you might be wondering is, you know, what's the changes with doing these additional upgrades to the units to meet these efficiency levels? So what I'm showing you here is from our energy calculator. On the left-hand side of the screen there, I've got condensing unit and evaporator number 1. So you can see at the bottom the total system power cost per year and the estimated power usage. And that would be the baseline. That's our standard model that you would have bought, say, last year. The next one here in the middle, condensing unit number 2 and evaporator number 2, that's with your ECM motors. And you can see what your new power consumption and power usage costs would be for the year. So when you factor in those savings over on the right-hand side here and you take a look at equipment costs, that's equipment cost only, no install in there. But basically you'll see your difference there with your energy savings of $234. Your payback's less than 2 years. So it is a pretty good payback, and it is good for the environment. Next slide, please. Now, the one thing that's a little bit different with this regulation is it doesn't affect all of the equipment in the refrigeration line. So, you know, condensing units that are serving multiple walk-ins, they don't have to comply. Water-cooled equipment's not part of it at this point. It's only air-cooled equipment. And again, walk-ins greater than 3,000 square feet, you don't have to worry about the regulation. So your compressor rack serving multiple loads, say in a supermarket, those are exempt. Your remote compressor units and air-cooled condensers don't have to comply. Reach-ins don't have to comply. So just so we're on the same wavelength here of what a reach-in is, reach-in would be, say, when you go to the grocery store and you're going down your freezer aisle, you open up those glass doors and you've got shelving in there and nobody can walk inside that cabinet. All right, that would be a reach-in. You might have a reach-in that's got a little more depth to it and it's got a man door in the back where people can go in and stock the shelves. That would be considered a walk-in. Now, it also doesn't apply to equipment for use in medical research or scientific applications. So, examples of those would be, blood freezer bank, pharmaceutical cooler, or anything where they're doing some research or testing. You would not have to worry about this regulation. Okay, next slide, please. Okay, so some important takeaways here from this regulation. So again, it's only for walk-ins that are less than 3,000 square feet, okay? Every component of the walk-in, whether it's a freezer or cooler, it must be compliant, and it's based on the date of manufacture of the product. It's not based on when you install it or sell it. So, if you've got something in stock or you're buying something in stock from a distributor that's before the dates of July 10th or January the 1st, then you are okay to install that equipment. So, and not only does the refrigeration equipment have to be compliant, but those boxes, those panels that you buy to make the box, they also have to have an AWEF value on them. So you're going to see some changes from the box manufacturers as well. Now, compliance with this regulation, it's required whether the equipment's for a retrofit or it's for a new installation. One thing that some of you might have been familiar with in the past is taking an indoor condensing unit, if you had one, and converting it to an outdoor model. And you can't do that anymore because of the labeling requirements of the regulation. We have to actually put on the nameplate whether that specific piece of equipment is for indoor or for outdoor use. Now, in terms of responsibility, so as the manufacturer, we have to make sure that the equipment we build, how we do our testing and certifying and labeling, that we do meet the regulation. When it comes down to the wholesale level, they got to make sure that the equipment that they're selling to the contracting community is compliant. All right, and then ultimately it falls onto the contractor to make sure the equipment going into the installation is compliant. Okay. Next slide, please. So you can kind of see there's a lot going on with this regulation. There's been a lot of confusion in the industry this year. A lot of people asking questions. When do I have to worry about AWEF? When do I not have to? Does this piece of equipment meet the regulations? So what we've done on our KeepRite website is we've got a section that's dedicated to the annual walk-in energy factor. So if you have any questions or that when you see this in the future, you can always revert back to our website, and we've got a frequently asked questions section. We'll tell you a little bit about what the regulation is and when you've got to be worried about it and what kind of efficiencies and stuff you have to meet. So that's a good site to check out. So it's www.ka-rp.com. Next slide, please. So again, I want to thank everybody for their time today to go over the regulations. As you can see, there's been a lot of change this year in the refrigeration industry. I don't think we've ever had so much change in such a short period of time. As I say, it is causing confusion out there, and it's a lot to digest. So, if you have any questions, let me know. Please feel free to reach out to me. I'm happy to help you with any questions you may have, any selections you need. I've got my contact info on the slide here. So I guess at this point we'll open it up for questions.
Yeah, if anyone has any questions, please type them into the Q&A box, and Amy or Jessica will forward them on to, will verbalize them and forward them on to Trevor for an answer.
If you'd like to ask a question verbally as well, you can raise your hand and we will unmute you to ask your question. Okay, Sam, you can go ahead and unmute yourself now and ask your question.
Can I get just a PDF for this presentation by any chance?
Yeah, so this
Yes.
presentation will be uploaded to YouTube and the PowerPoint slides will be sent out later today.
Okay.
Paul, you can unmute yourself and ask your question.
I'd like to ask a question about the replacement refrigerants for 134A. Like, what are we going to be running into that, and what's the some of the characteristics of it? I assume it's relatively the same as 134A, but I don't know. Haven't run into it yet.
Sorry, Paul, I didn't hear the first part of your question there.
About 134A, what the characteristics of it are, if there's anything we have to look out for with it. Is there anything in particular we should need to know about it?
No. 134A, say it's been around
The
for
replacement, sorry, the replacement for 134A.
Replacement for 134A. So again, what you could use is our 448A, 449A, 407A or C are kind of the main ones out there, and they all have similar operating characteristics. Now, usually with 134A, you do need a little bit more horsepower to get the same amount of capacity, so you might find that you can actually use smaller equipment with the newer refrigerants.
Okay.
Does that answer your question?
Somewhat, I guess, you know, I guess like you're not going to really learn everything until you actually get in there, right? So, but if we're doing some conversions, what's the ideal way to convert?
Sorry, I didn't hear the last part there.
If you're doing some conversions from 134A to a replacement refrigerant, what's the ideal refrigerant to use?
I really would say there's an ideal refrigerant. Like there's multiple choices there with the 448, the 449, and the 407 series. What you do have to kind of take a look at is, you know, do you have to do any changes to any kind of seals or gaskets? Obviously, TX valve's probably going to be different. So just some things you got to consider there.
Well, that's what I mean. If I have a piece of your equipment that's on 134A and it needs to be converted, say there's no gas in it, and so the leak has to be repaired, and we can't buy 134A anymore. Well, I can still get it, but it's going off the shelf. What do I put in it to be current with refrigerants? And is there some parameters? Because there's obviously whether you're a freezer or you're medium temperature, because some refrigerants are great at medium temperature but won't do your freezer, et cetera, et cetera. So,
what are those refrigerants I mentioned there?
is there information on this out there, or what? I haven't really seen a lot of information flying around about this.
No, the best place to look in terms of capacities and what you can use for medium temperature and low temperature, if you take a look in our product manuals for equipment, you'll see that, you know, 407C, you wouldn't use that in a freezer, but the other refrigerants there, you definitely can. And capacity would be similar.
Yeah, okay. Okay.
Okay, great. So we have a question in the question and answer box from Nina Morgan. Will we see more scrolls in the 3 HP and getting underway from semi?
Sorry, Amy, can you repeat that? I had a hard time hearing you there.
Yeah, it says, will we see more scrolls in the 3 HP and getting underway from semi?
Yeah, with the new regulation with our equipment, you're going to see that the semi-hermetic compressors, they start at a higher horsepower now. So I think the smallest you'll see in medium temperature is a 3 horsepower. And then you're going to see the scroll taking over more on those smaller sizes as well, because they're rated for the multiple new refrigerants that are out there. So you'll definitely see the scroll gaining popularity, probably used more than the hermetic compressor, but yeah, you will see more scroll and semis probably being used now.
Awesome. It looks like no one else has their hands up and there's no questions in the question and answer box, so we'll just move on here.
Okay, well, thanks, Trevor. Thanks for spending the time to enlighten us on a very relevant and ever-evolving topic. If anyone would like to contact Trevor directly, his contact info is on the screen there. As some of you may already know, KeepRite Refrigeration has sponsored an awesome giveaway for this episode. We'll be raffling off a $100 Amazon gift card along with some ORAC swag for all of you who have registered and attended this episode. The winner of the contest will be announced tomorrow at 2 p.m. on social media, so make sure you follow us at ORAC Association on Instagram, Facebook, Twitter, or LinkedIn to stay in the loop. Thank you again for attending this episode of ORAC 2.0. We hope that you gained some valuable information during the webinar. Stay tuned for our upcoming episodes as shown on the screen. Invitations to register for these webinars will be sent out closer to the date. Thanks again to everyone for attending, and thank you again for Trevor, and have a great day, everyone.